Hello everyone. In this video, I am going to tell how to solve a Z bus matrix, that is impedance matrix problem. Normally, for solving impedance matrix problem, we will be having some steps. The first step is adding a bus to the reference. We will be considering a bus, a ground as reference, and we will add the first bus to the reference. That is the first step. Adding all the buses, all the possible buses to the reference. Then adding a new bus to the existing bus. That is the second step. Then adding an existing bus to the reference. Then adding a bus between two existing buses. Normally we had these methods. Adding a first bus, adding a bus to the reference. Generally we will say adding a bus to the reference. Adding a new bus to an existing bus. Adding a admittance between two existing buses. When we are adding a bus between two existing buses, we had some procedure. And then for solving, when we are adding a existing bus to reference, the size of the bus matrix will be increased. To reduce that, we had different methods. We can use cron reduction method, and there are many other methods. I follow this method. Let me tell you. First of all, this is the given question. This is the given question. In this question, I am assuming this bus 3 as reference bus. So, first adding a bus to reference. So, I can add 1 to reference bus, adding 1 to ground. Then, adding a bus to existing bus. When we add 1 to reference, 1 will become an existing bus. So, now we are adding a new bus 2 to an existing bus 1. That is the second step. Then, adding a bus to reference. Now I had added, first step I had added 1 to reference, then 2 to 1. Then now I am adding 2 to reference. 2 to reference. Actually, okay, instead of taking 3 as reference, since they had mentioned the ground, we should take ground as reference. If they had not mentioned the ground, then we should take ground as reference. So in this, 3 is not reference. Adding 1 to reference. This is the reference. This total ground is the reference. Adding 1 to reference, that is J.02. Then adding 2 to 1, that is J.8. Then adding 2 to reference, that is J.4. Then you can add 3 to either 2 or 1. You can add 3 to 2 or 3 to 1. What I had done is, I had added 3 to 2. Since I had added 3 to 2, adding a new bus to an existing bus, now there are no new buses available. We had added 1 to the reference, that is a new bus to the reference, and 2 to the 1, that is new bus to the existing bus, 2 to reference, then 3 to 2. 3 to 2 now, new bus to existing bus. Now we need to add this 0.4 between two existing buses. So the final step is adding an impedance between two existing buses. First thing, adding 1 to ground. I prefer always to take 1, as in some problems, there will be the ground is attached to only 1 bus. Assume that as the first bus. If it is first bus, no problem. Suppose the bus which is immediately attached to the ground is not first bus, you change the numbering. You change the, suppose you have, for ground, bus 2 is attached. Then you interchange bus 1 and bus 2 numbering and solve the problem. After solving the problem, you will get final Z bus. In that final Z bus, you interchange the 1 and 2 rows and 1 and 2 columns. Why? Because in the beginning, to avoid complexity, we had interchanged the bus numbers. Whichever connected to ground, we had taken it as 1. If possible, we will see that problem also. Okay, coming to this problem, first adding 1 to ground. So J.02. Now adding 2 to 1. This is whenever we are adding a new bus to the existing bus, the existing bus is 1. So repeat this 1 as in row, in column. So you should repeat this J.02 here and here. When commit to 2 element, Z22 element, add the value of impedance of existing bus, that is 0.2 plus the impedance to be added, that is 0.8. Now we will get this. Now we are adding 2 to ground. Now when we are adding 2 to ground, you repeat the second row, that is these elements. 2, 1 and 2, 2 elements here as well as here. Whenever we are adding a bus, we should repeat the previous row. Since we are adding 2 to ground, you repeat this J.2 and J1 in the next row and the next column, and J33 element will be the J22 element plus 2 to reference. You are adding 2 to reference, that is J.04. So you will be adding that. Now you got this. If you observe after step 3, actually we had only first bus, second bus. We should not consider reference bus. We had only 2 buses available. But what happened here? It came a 3 by 3 matrix. Whenever we added only 2 buses, we should get 2 by 2 matrix only. So we got 3 by 3 matrix. Now there are many methods to convert this 3 by 3 matrix into 2 by 2 matrix. In this problem, I am using Cron reduction method. In Cron reduction method, we are finding the desired matrix is a 2 by 2 matrix. The available matrix is a 3 by 3 matrix. In the desired 2 by 2 matrix, Z11 element will be given by Z11 old minus Z13, Z31 by Z33. Z11 old is the first Z11 element of this 3 by 3 matrix. Z13, Z31 and Z33 are the elements, corresponding matrix elements of this old matrix. Similarly, Z12 new is equal to Z12 old minus Z13, Z32 by Z33. Similarly, Z22 new is equal to Z22 old minus Z23, Z32 by Z33. By solving these 3 things, since Z21 and Z12 both are same, you don't need to find it again. So you will be getting a 2 by 2 matrix. The generalized formula for Cron reduction is Zij is equal to Zij minus Zin plus 1 Zn plus 1j by Zn plus 1 n plus 1, where n is the desired matrix. See, n is 2, that is the desired matrix size, 2 by 2 matrix. I will repeat the formula once again. Zij is equal to Zij old minus Zin plus 1 Zn plus 1j by Zn plus 1 n plus 1. Now after solving, whenever we are adding, first thing we had added bus 1 to the reference, new bus to the existing bus. That existing bus to reference, the size will increase. To reduce that size, we will be using many methods. One among the method is Cron reduction method. After doing the Cron reduction method, we had added what we had added. Now we had added 1 to reference, 2 to 1 and 2 to reference. Now I am adding 3 to 2. When I am adding 3 to 2, adding a new bus to the existing bus, it is again same. You will be repeating. See, adding 3 to 2, you will repeat this J.0571, J0.2857 in the third row and third column, and the last element will be sum of the 2. Now we had added everything. The left is between 1 and 3. 3 is already available in the system. Why? Because in the previous step, we had added 3 to 2. Now 1 is also already available in the system. Now we are adding the impedance between 2 existing buses. This is another different type of calculation. See carefully. Now, whenever we are adding 3 to 1, that is the impedance is added between 2 existing buses. The fourth row, that is the next row or next column, will be difference of the 2. That is, you can take 1 minus 3 or 3 minus 1. I had taken 1 minus 3. This first element in the 4, this first element 1, 4 will be given by 1, 1 minus 1, 3. Similarly, 2, 4 will be given by 2, 1 minus 2, 3. 3, 4 will be given by 3, 1 minus 3, 3. Similarly, 4, 1 will be same as 1, 4. Even you can subtract this 1, 1 minus 3, 1. It will give same. First row minus third row is equal to this fourth row. You can write these three elements directly here. Otherwise, if you want to check, you can check. First column minus third column will give you the fourth column. Now this 4 element, last element is the formula for finding 4 element is. Now here we are adding the impedance between 1 and 3. So the formula will be Z11 plus Z33 minus 2 times of Z13 plus ZB. The ZB is the impedance to be added between 1 and 3. By using this formula, you will be getting the matrix which is 4 by 4 matrix. But if you see the diagram, in this diagram, we had only 3 buses. So again, we need to reduce this into a 3 by 3 matrix. So again, you should do the Cron reduction. So this is the final Z bus. Now in the next problem, what they had said, they said that the impedance between 3 and 1 is removed. Whenever they said they had given, sometimes they will give the final Z bus in the question and they will tell in this Z bus, they won't give the diagram. They will use the Z bus and they will tell the impedance between some 2 buses is removed. Find the new Z bus. Then how to proceed. See here, now in the next sum, they had said the impedance between 1 and 3 is removed. Suppose you don't know this diagram. They had given the final Z bus and they said, in this Z bus, if the impedance between 1 and 3 is removed, find the Z bus of the new system. What you should do, you should add an impedance. Since between 1 and 3, the impedance is removed. How can I know that? By adding an impedance minus J.4 between 1 and 3, I can get the impedance of the new system, which does not have an impedance between 1 and 3. You will understand once you see this. See here. Now, previously we had this J.4 between 1 and 3. The Z bus obtained overall is this one. Now, when a transmission line between 1 and 3 is removed, we add an impedance with a negative magnitude between 1 and 3. So, if you add a negative, again we are adding a impedance with a negative magnitude between 1 and 3. What it will happen? Adding minus J.4 between 2 existing buses. So again, you will do the same procedure what I had explained. Again, you should do the Cron reduction method to obtain the final Z bus. So in this Z bus, if you see the steps of solving Z bus are adding 1 to reference. If 1 is not connected to reference, if any other bus is connected to reference, interchange the numbering of that. And finally, after solving everything in the final Z bus, you interchange the 2 rows and the 2 columns to get the correct answer. In this problem, 1 is added to reference, so no problem. So first step, add 1 to reference, add a new bus to an existing bus, add an existing bus to the reference. When we are adding an existing bus to reference, the size of matrix will be more. Reduce the matrix size using any method. Then add an impedance between 2 existing buses. Suppose you are adding an impedance between 1 and 3, then I said the 4th row and 4th column will be either 1 minus 3 or 3 minus 4, and the Z44 element will be Z11 plus Z33 minus 2 times Z13 plus ZB. With this, I will end the problems. With this, I will end the video of Z bus calculation. Thank you.